Hello, welcome back to this series on object-oriented development with MQL4. Today I'm going to be creating this dashboard that you see at the bottom of the screen. As I've mentioned before, the information here is whatever you choose to display. The topic for today is how to create the dashboard itself. If you haven't seen the earlier videos, I recommend that you go and see those, and I will leave a link in the description for those because we will be looking at some of the functions that were already created in those, and it will make more sense if you see the earlier videos first. For today we're creating this dashboard. So let's review what we have here. It is in a separate window or sub-window of the chart. It has multiple columns, so one dashboard has several columns. Each column then has a number of rows, and each row has text, font, size, and color. So a column in itself is very similar to the dashboard we created earlier. We're now creating multiple columns in a single dashboard. So let's look at the code and see how we do this. When you think about each of the columns in the new dashboard, each one of them is almost the same as the simple dashboard that we created in earlier videos. So I'm going to save some time and inherit from the last class that we created for that dashboard. But because we were rushing through and I try to keep the videos short, I took some shortcuts. I'm going to fix those now to make this base class or this dashboard v2 class suitable as a base class. I've already loaded it up here. I've included a comment that I'm making this suitable as a base class, and I've updated the version number. So now let's see what we need to do inside the code. The dashboard row doesn't need to change. It's got the same information as before. Where I have made these variables private before this, I now want them to be inherited into a subclass. All I really need to do is make this protected. Now all of these are available to any class that inherits from C dashboard row v2. Also, because I'm now putting the dashboard into a sub-window, I need to track that sub-window so that this class will know where to draw itself. The text that we're drawing on the screen inside the dashboard are label objects, and each label object in the window needs to have a unique name. So previously we've been using this text object name function, which simply took the unique name that we provided for the dashboard and then the index, which is the row number of that line in the dashboard. But now I've got multiple columns as well, so the format for this needs to change. I've not only got multiple columns, but I may also have more than one dashboard if I'm using more than one sub-window. This is entirely suitable then for the simple case, but I want to extend this so that it can be used in a base class or in a subclass where the format might change. So let me add a couple of rows here to show you what I mean. I'm going to create this function called textObjectPartial, which gives me a partial name, which is basically everything except for the index number. I'm creating that because if you remember in the DeleteAll and various other places where we're trying to remove all of the objects from the screen, we're using the shortcut that takes the base of the name of those objects and deletes everything matching that base. So I'm creating a single function for that, and I'm making this virtual, and that will allow the subclass to override this with the format that's suitable for the subclass. And then just to make sure that everything remains consistent, I'm going to replace textObjectName with a new function, still called textObjectName, that uses the textObjectPartial function rather than build up the entire string itself. That way, as the subclass overrides textObjectPartial, it will also create a new textObjectName. Let me get rid of the old function here. I've made both of those virtual, but when we get to creating the subclass, I don't need to override textObjectName. I only need to override textObjectPartial. I also need to make the DeleteAll function virtual. I won't go into too much detail about that now. It'll be clearer when we create the subclass. But clearly this DeleteAll function is going to try to delete everything from the screen. I want to add some extra conditions around that in the subclass. Now, going down to the constructor, I've been setting the corner to a default value here, but now I've added the sub-window, so I'm also going to set the default value for the sub-window. And because I still want to be able to use this V2 class as a standalone dashboard, I'm going to default to SubWindow 0, which is the main window. And the last change for now to make this suitable as a base class is in the function to draw the row on screen. Let me just scroll down here. This used some defaults previously. This window has been defaulting to 0, and this is also the window number. So I'm going to now replace these with the variable we created for the sub-window. So this class still works as it stands. The sub-window will default to 0. It will be a single column on screen, but now when I override this in a subclass, then I can change the sub-window number, and that should be everything we need to do for now. There is one more change that I'll come back to because it'll be more obvious when I get to that point. One more change that I forgot, I did mention it. We're going to change the DeleteAll. This is where I said previously I've been just hard coding the short form of the name here. Now I'm going to replace that with my text object partial function. And this way the subclass, simply by overriding text object partial, can use the same DeleteAll function to delete everything. And there's another change that I want to make. This has nothing to do with this being a base class. I just want to make the class slightly better. In the past, the only way to add new rows was to call the add row function. I'm going to improve the set row function to let you specify an index that is not already in the array, and then it will add additional rows to create that index. So this one function can be used to also create new rows. All I need to do here then is add, if the index is less than 0, then I'm going to add a row. So any index below 0 will simply work the same as the add row function, because it will just create the next row. And an index greater than the size of the rows will loop through here and add rows until we reach the index specified. And because I'm going to be able to add rows at an index that doesn't already exist, I can remove this check for a valid index. Now that I've modified the dashboard v2 so that it's suitable as a base class, I can go ahead and create the dashboard column class. So here it is. Simple comment blocks. I'm including the dashboard v2 MQH file. This is my C dashboard column class, public inheritance from C dashboard v2. I'm adding one member variable to this that doesn't exist in the base class, and that's the column number, because the base class has no need for a column number. Here is where I'm overriding the text object partial. If I scroll to the right, the partial name of the label objects that I'm going to be creating here have the unique name that's supplied, the sub window, and the column number. So 3 components to that. And I'm overriding the DeleteAll, which we'll get to in a moment to see why that's changing. Here's the standard constructor for this class. In this case, I'm passing in a name, the sub window, the column, x distance, and y distance. What I've added to this is the sub window, and I've removed the corner because everything in this dashboard will be a top left corner. And then to deal with the, and I've also added the column number. And to deal with the sub window and column number, I'm now creating a new init function that takes those two. I don't need the init function for the rest of these values, and you'll see that in a moment when we get to the constructor. I've also added one property for GetSubWindow, which simply returns the sub window passed in. All of the other properties, the x distance, y distance, everything else, are inherited from the base class, so I don't need to recreate those. So here's my init function, simply passing in the subwindow and the column number, and then all I'm doing is assigning those to the member variables for subwindow and column number, and then I'm going through the DeleteAll function to delete everything from that column that might or still exist on screen from a previous run. The DeleteAll function itself, remember I'm overriding this from the base class. All I'm doing here is checking if the column number is less than 0 or the subwindow is less than 1, then return. And this is simply to stop this being executed before the column number or subwindow have been set, because if the function is called before that, it would simply delete all the objects from the screen, not just for this column. And once I've done that check, I can then go ahead and call the DeleteAll function from the parent class by simply calling c-v2 : DeleteAll. Now let's go back to the constructor for the subclass. I didn't show this previously because I want to explain something in a little more detail. This would be the typical constructor for the subclass. I'm calling a constructor with the new arguments for the subclass itself, adding in the subwindow and the column number. Typically then I would call the constructor for the base class, passing the arguments needed for that. So the name simply comes from this name argument. 0 is where I would be defaulting the column or the corner for this column. The x distance and y distance also coming from these arguments. And then I handle the column number initialization to -1 just before I call the init function to set that, and then I pass subwindow and column into the init. In this case, however, the constructor for c-v2, which if I go to that, the constructor calls its own init, which is fine, setting name, corner, x distance and y distance, but that init function then calls DeleteAll. In this case, because that is being called from the constructor of this class, it will not call the overriding functions in the subclass, meaning that this DeleteAll will in fact be the DeleteAll for the c-v2 class, which will bypass the test that we put into the DeleteAll function in the dashboard column class. It will also call It will also call this text object partial function, which will not return the correct partial object name for the subclass. That's just a function of having called it through the constructor. So to avoid that, I'm not going to call the constructor of c-v2 from the dashboard column class. Instead, and I'll just replace this with the function that I am going to use. So same arguments, name, subwindow, column, x distance, y distance. I'm still initializing column number to -1, but now I'm directly calling the init function from the parent class. I don't have an init function with the same arguments here, so this will call the parent class. If I wanted to be specific, I could always put call it like so, which would guarantee that I'm calling the init from the base class, but I don't have, as I said, another init function with the same signature, so it will go to the base class. In this case, because it's being called from the constructor of my subclass, all of the virtual functions will be calling the virtual functions in the subclass. So this will call the DeleteAll function that we created down here, which will run this test, and as we saw, I am setting the column number to -1, so that test will fail when this init function attempts to call DeleteAll, and it will come out. And then in my init function, I'm calling DeleteAll from the subclass, which cleans up all of the objects on screen from this column only. This is also one of the reasons why I like to call init functions from my constructors rather than put the code in the constructor, because now I can call this init function from here without needing to go through the constructor for the base class. You also may have noticed I don't have any deconstructor. or destructor for this class. There is nothing for the destructor to do other than the DeleteAll function, which is already being called in the base class. So I'm just relying on the destructor from the base class here. There's one more change that I need to make because of this. Because I'm not specifically calling a constructor of the base class, then the default constructor is going to be called. And if you remember from earlier videos, I didn't create a default constructor because I don't want the class to be created with no values passed in. But now I have to have a default constructor. So what I'm going to do is scroll up to, so this is the default constructor that I commented out earlier. But if I take that and make it a protected function, and all I need to do here is put two brackets because there's nothing to do inside that function. By making it protected, then it's still not possible for any application to create an object of type C dashboard v2 passing in no arguments, but the child classes of this that inherit from this class can call that constructor. So that will all work. Let me just do a test compile to make sure. Well, DeleteAll is a private member function. Just a moment. Yes, here I forgot to change this to protected. Right. Alright, so that change was in the parent class. I had left these functions as private. Now they're protected. I'll also change, I've forgotten I should change this as well. I'm not calling these from the subclass, but there's no reason to hide them from there. I don't think I've got any other private declarations here. Right. So all I've really had to do is change the constructor and one class to override for a condition, and then through inheritance I've managed to create a column class that inherits directly from the dashboard we've created earlier. So now let's move on and create the dashboard class. Now to the actual version 3 dashboard. I've already created it here, dashboard v3, standard comments. I'm including my dashboard column class, dashboard column.mqh, class definition C dashboard v3. Now my member variables. I have an array of columns now, so of type C dashboard column, an array of columns. There is a name for my dashboard. My dashboard is inside a subwindow because it's possible to have more than one subwindow on the screen, so it needs to understand that. The x distance here, instead of being the x distance of one column, is the default margin around each column, and you'll see when we use that. And the y distance is of course the same value on each column, but I'm holding a member variable inside the container class so that I can set that y distance for each column. Get column width, because I've got multiple columns, I need to calculate how much space across the screen I'm going to use per column. CreateColumns is just a useful function so that I can create one column at a time, and then the DeleteAll will clean everything up for me. My constructors, I have two constructors. The name, which is the generic or the unique name that you need to create the dashboard as. Subwindows are numbered in MetaTrader, so I've got a constructor here that takes the SubWindowID, and then of course the number of columns to be created, the x distance and the y distance. But to make life a little easier, I've also created a constructor that uses subwindow name. If you look at subwindows, then they have a name in the top left corner, which is typically the arguments that are passed into an indicator that might be on that screen. But if we're going to use this for a dashboard, then we'll need to create those windows, give them a name, and then I can simply pass that name in here rather than the window ID, which saves the trouble of the calling application from identifying which window to use. And then of course the destructor, which just calls the DeleteAll function. Because I have two constructors, I have two init functions calling the same arguments as used in the constructors. and then I now have a redraw function that simply changes the X distance of the overall dashboard, and that causes everything to be redrawn, as you'll see in the setXDistance function. The functions I got is valid. That tells me if I have a valid subwindow. Anything that is less than 0 is not a valid subwindow and will cause this to fail. And an override to that, passing in an index, will firstly check that I have a valid subwindow and that the index, which is a column number, is in the allowed range of columns that I have. Properties. Now here, one of the properties I have is to return the column number. So this will be used by the application to set values on a column. There are two methods of setting the values on a column. I've chosen this method where I'm exposing the column object to the calling application. That means that certain features of that column that I may not want to give to the application become available. And one of those, if you remember from earlier, we have a corner property that could be set by the calling application. So by using this technique, the entire column is available to the application, which can then set corner. And in this case, I don't really want the corner to be anything other than top left corner. So this is exposing a potential flaw. I know that I'm the only one calling this, so I'm happy to use this method. The alternate method would be to expose each of the properties of the column that I want to show. It would be something like set row text, and you would pass a column number in here, and then this function would in turn call the column and set that value. That would allow me to control exactly which properties I'm exposing to the calling application, but it also creates more problems in the future. If I want to enhance the column in any way, then I have to remember to expose those enhancements through here as well. Given that I know that I will not set the corner, I'm comfortable with using the shortcut form here and taking it easy. Then I simply have some standard properties. Get the name, which is returning the name that was set earlier. Get the SubWindowID. There is no function to set the SubWindowID. The only way to change that will be to completely restart and recreate this object. It's just such a big change to change the SubWindowID that it's easier to simply say start again. Column count is simply returning the number of columns that we've created. X distance and Y distance values get and set. In the constructors, I'm really just calling the init functions, so there's no actual work happening here, but I am initializing the SubWindowID to -1 before I start, just to make sure that it's completely invalid in case something goes wrong. Then in the init functions, firstly the init function that uses the subwindow name, I'm using the chart window find method to find a window of that name, which gives me a SubWindowID, and this will return a negative value if there is no subwindow with that name. And then I'm simply calling the init function, passing in the window ID that I got from that function. The init function then, based on SubWindowID, all I'm doing is setting the values for the name, SubWindowID, X distance and Y distance. DeleteAll will just remove all of the columns that may be in memory, and then I simply go through and create the number of columns specified in the columns argument. The DeleteAll function, all I'm doing here is calling the DeleteState, always deleting each column one by one to clean up the memory, because these columns are objects. If I don't delete them, well, they are pointers to objects. If I don't delete those, then it will consume memory and eventually just cause that memory usage of MetaTrader to increase. And then all I'm doing is resizing the array of columns to 0. CreateColumns function, depends how many columns we're passing in. Checking to see if we have a valid subwindow. Column width, then I'm calculating the width of columns, which is just below. We'll see that in a moment. But these are dynamically sized columns. So 2 columns will take half the window each, 5 columns will take 20% each. So I'm simply calculating constant width based on number of columns. Then I'm setting the columns array to the number of columns I use, and then simply looping through and creating a new dashboard column by calling the CDashboard column constructor. The column width function, based on number of columns, I want to get the screen width, which I use the chart get integer function for, which tells me the screen width in pixels for the given subwindow ID. Then column width is simply a division of screen width divided by number of columns here. Here's the property to return a single column. It's returning a pointer to a CDashboard column, and all I do is check that the index is valid, and then I just return the item from the mcolumns array based on the index. Set X distance. So this is setting a default X distance for every column. Without this, column 0 would be hard up against the left hand side of the screen, and then each column after that simply starts their percentage across the screen. By setting this value, I'm creating a small border to the left hand side of each column. So first the isValid check, then I'm getting the column width. So number of columns comes from the size of the columns array. Calculating the column width, the same thing that we calculated above. And then for each column, I'm setting the X distance of that column to be equal to the value passed in. So this is the margin per column, plus the column number multiplied by the column width. So I'm effectively setting the left side of each column based on its position across the screen. And then once that loop is complete, I store the X distance that I've passed in here. Set Y distance, very similar, but I don't need to calculate any width of columns. I'm simply assigning that Y distance to each column in a loop. And that's everything for the container class for the dashboard. So next we'll look at an indicator that just uses this to display the dashboard for us. Now here's my dashboard example indicator I've already created. I'm setting the property indicator separate window. If you remember, same window or separate window will determine whether the indicator is in the main chart window or whether it creates a secondary window, something like the MACD window that appears at the bottom of the screen. I want this in a separate window because that's where I'm going to draw the dashboard, and that way it doesn't clash with anything in the main chart window. I've included my dashboard v3 header file, or MQH file. I'm declaring a pointer variable dashboard of type CDashboard v3, and then symbol list and indicator name. You'll see those soon. Indicator name, as I mentioned, each indicator has a name on screen and gives that name to the sub window. I am simply creating a almost random number here based on the current time. There's no meaning to that other than to create a name. And then I'm using the indicator short name to set the name of that sub window. Then I'm creating multiple columns on screen. I'm not doing anything very imaginative with this. I'm simply going to use 5 different currencies and draw the same thing for each of those currencies. So to make my array of currencies, I'm going to be creating 5 columns, and I'm using the string split to just create that array. So then I'm creating my setting my number of columns based on the size of that, and now I'm initializing the dashboard. So it's a new CDashboard v3. I'm still giving it the name test, the indicator name so that it can find that sub window that I've created, number of columns based on the number of elements in this array. I'm setting an X distance of 2 from the left side and a Y distance of 15. And then I'm simply calling an update dashboard function here. Let me scroll down to the update dashboard. And I'm looping now through my symbol list and gathering some information on each symbol. The bid, ask, spread, open and close prices, and then I'm setting the values in the rows. This is the same sort of function that we had previously where I had the single dashboard, but now we can see that for the dashboard object I'm calling the .column function to return a specific column, and where previously I was using the add row, if you remember, I now modified set rows so that it will add the columns for me. So I'm just calling set row straight away from here. So I'm just calling set row immediately here. Row 0 is just the symbol in white, bold, 12 point, and then I'm showing the directional arrow that we've had before and setting the other values. And because I can now call the set row function, I can call that the update dashboard directly from the initialization function here, and I can also call it from the loop here, so using the same function. And then of course when the indicator terminates, I just delete dashboard to clean up the memory. And on chart event, in case the size of the window changes, and we'll demonstrate that in a moment, I want to redraw the dashboard. That's why I've created that redraw function initially, because it's now in a separate panel. If I were to shrink the size of the window and did nothing else, some of those columns would disappear off to the side of the window. So this will call the redraw function when the window changes. So here is that indicator running. These are the 5 columns that I defined, each one getting the values from their respective currencies. And the redraw, let me just resize this window. You can see that each of those columns is now resized to fit the this number in the top corner is the name of that window, or that sub-window. That's always there, and that's one of the reasons I set the Y distance to 15, because that name will always be on screen, and a size of 15 just allows me to put the first label below that. So that's a working dashboard in a separate panel. It keeps everything away from the chart. I can put any indicators on this chart that I like and they won't affect that. I can even add other indicators that have a separate panel. Let me just add MACD, and it will create a new panel so it won't conflict with this. There is one thing to note. I've written this as an indicator, and there was a reason for that, because I need to create this indicator separate window. If you're attaching this dashboard to an expert advisor, you don't have that option to put the indicator in a separate window. So in the next video, I'm going to show you how to put an expert advisor dashboard in a separate window. It will be using the same dashboard v3 class, but I'll just show you the technique for putting that into a separate window. And then we'll also begin to build the functions and classes to be able to display this dashboard in a window where you're not running the EA. As I mentioned before, you might be running your EA on a VPS. You don't necessarily want to log into the VPS to see the dashboard. It's nice to be able to run this on your local computer and see information that's been fed down from that VPS. So I'll show techniques for that. They're not without their own problems, but it might be more useful than having to log into the VPS. And then we'll move on after that and ultimately build up an expert advisor using the various tools that we've created. I hope you're finding this series useful. If you are, then please leave a like. Any comments, if you've got any questions, if I've gone through anything too quickly and you want more explanation, please leave the comments below, and please subscribe and hit that bell icon to be notified when I release more of these videos. Thank you for watching.